Hey, physics family, we are back with some more math review. This is the extra math review practice, which is often the backside of a worksheet we're working on. So let's dive into it. We're looking into scientific notation, and I know for some of us, we've worked on this before, and some of us, we haven't had a lot of experience. So let's make sure we review again. Don't forget, scientific notation always has a number with a decimal point, and then maybe some other numbers, and then it's always times 10 to the something powered. So you're going to have an exponent. So the rule is that you find the non-zero digit furthest to the left in a number. In this case, for this number, it's 3. And then what you want to do is you could times 10, and then you have to figure out what number of decimal places does it take to get it back to where it was. So let's think about that. The decimal would be right here after the 3. So I go 1, 2, 3, 4, 5, 6, 7, 8 places to get that decimal back to where it was. So it would be 3 times 10 to the 8th. Now, occasionally that throws people off because they're like, well, oh, where was the decimal? Remember, if you don't see a decimal, the decimal is always to the right. It's after that last 0. So, and don't forget, throw in your units. It's just good habit to do. And sometimes I forget too, but let's hold ourselves accountable. Next number looks like 4 is the furthest to the left non-zero digit. So I'm going to put 4.5 times 10 to the what power? And now I got to figure out how to get backwards to where that decimal place was. So I'm going to do that. I started between the 4 and 5, so I'm going to go 1, 2 place, 3, 4, 5, 6, 7. So I'm going to go backwards 7 times, which means I'm going to put it times 10 to the negative 7th. Remember, the negative exponent makes the decimal point go backwards to the left. Positive exponent, like a number 1, makes the decimal go forward. Hopefully that helps. Next up, number 3, looks like the furthest to the left non-zero digit is 3. So I'm going to do 3.6 times 10 to the... And if I have my decimal between the 3 and the 6, I'm going to go back 1, 2, 3 places. And that means I'm going to have it to the negative 3rd power because I had to go to the left 3 times. So it's a negative. How about 5,800? That's going to be 5.8 times 10. And now that I have my decimal between the 5 and the 8, it's going to be 1, 2, 3 places to the right. So that's a positive 3 exponent. And look what I did. I forgot. Use my units. Don't forget to carry them. That's valuable and a good habit to get into. So hopefully that helps a little bit. And let's move on to number 5, which is the metric system. Remember, King Harold died by drinking chocolate milk. Kilo, hecta, deca, the base. Deci, centi, milli. Also, don't forget, for the base could be grams, liters, seconds, meters. Could be a lot of other things too, but those are the ones we tend to be most used to. So let's go ahead and rock it. I'm going to go from grams to kilograms. So what does that mean? Well, grams is at my base. Kilo is over here. So I'm going to need to go 1, 2, 3 to the left. So I'm going to take my number 147. Remember, if there's no decimal, it's really like it's after the 7. And I'm going to go 3 places backwards. 1, 2, 3. So that means I'm going to end up with 0.147 kilograms. Next problem, 1.1 meters to centimeters. Now, easy problem, easy accident people have. Remember, meters is a base unit. That's not meters right there, right? That stands for milli, like millimeters. Millimeters. So careful. So many people accidentally make that mistake. But I'm going to go from meters to centimeters. So I'm going to go 1, 2 places to the right. So if I start with 1.1, I'm going to go 1, 2 places to the right, which means I'm going to make this 110 centimeters. Hopefully that helps. Next up, sometimes people overcomplicate. Don't. All right? It's just mathematical operations. First thing, number 7, all of them are in centimeters, and you're adding them. So good news. Just add them up all on your calculator. 6.201 plus 7.4 plus 0.68 plus 12.0 gives you about 26.28. Most importantly, what are the units? because you just added them, it stays centimeters. It's not like centimeters to the fourth power or anything like that. When you add, the units stay the same, but you have to have the units the same in order to do that. So pay attention to that. Like number 8, both in kilometers, so I can add up 5.06 plus 8.124, and I end up getting about 13.184. Most importantly, what are my units? It's just kilometers, kilometers. Why? Because when you add up 2 sets of kilometers, it still stays kilometers. It's not like kilometers squared. They're not being multiplied. They're just being added. Take a look at number 9, both grams. So I know my answer is going to be in grams because it's a subtraction problem. Do 10.8 in your calculator minus 8.264, and you get 2.536. No problem there. Next one is subtraction. Luckily, they're in the same units, meters and meters. Subtract them, and what do you get? 474.5832, and meters is there. And yikes, my handwriting is a little rough on this iPad. My apologies. All right, number 11. Now, this is important. Centimeters times centimeters. So you're doing 131 times 2.3. When you multiply those together, you get about 301.3, but centimeters times centimeters means it's going to be centimeters squared. Don't forget that. When you multiply, you have to multiply the units too. Check out number 12. Multiplication, both in meters. So you know meters times meters, your unit's going to be meters squared. And now I can just plug that into my calculator. I get about 13.597. Perfect. The most important thing, though, is remember meters squared. I know you guys can plug into your calculators. How about 13? It's going to be centimeters divided by seconds. What's the unit? It's going to be centimeters per second. Super important to remember that. It's easy to forget. But so throw 20.2 divided by 7.41 in your calculator. You get about 2.73. But most importantly, did you remember the unit is centimeters per second? It becomes a rate. All right. Number 14. Look at that. I've got meters divided by seconds. That means it's going to be meters per second for my units. And if I take 3.1416 divided by 12.4, I end up with about 0.25 meters per second. So the math, no issue. Just plug in your calculator. However, the units, pay attention. If you're multiplying or dividing, you're going to change your unit. If you're adding or subtracting, your unit should stay the same. Let's carry on here. We want to rearrange our equations so that we solve for V. So if we take a look at D equals V times T, if I want to solve for V, I just need to get V alone. So I'm going to divide both sides by T, get rid of T, and what ends up happening is D over T equals V. So I officially solve for V. This is great just for rearranging equations when we learn in physics, but also being able to just practice your algebra skills. You know, what do you need to do to isolate that variable, we would say. Here we go. Let's check out the next one, number 16. T equals D divided by V. By the way, I like to rewrite it with D over V. I think it helps me in solving. My next step is I don't like V in the denominator. I'm going to get it in the numerator. That's going to help me. So I'm going to multiply both sides by V. By doing that, that is going to allow me to, and forgive me, I'm going to move my work over here. That's going to give me V times T equals D left over. Now, I don't want V with anything, so I've got to get T to the other side. So I'm going to divide both sides by T, cross out T, and what do I finally get for my answer? V is all alone, and V equals D divided by T. So we solved for V on that one as well for number 16. We are now on 17. Let's rewrite 17 to make it look a little bit more visually appealing. I'm going to put V squared on top over 2D. Now that I have it like that, I feel like it's a lot easier to see. I need to get rid of 2D to get V alone. So I'm going to multiply 2D to both sides. That's going to cancel out my 2D, and I'm going to be left with V squared. So that means on this side, I now have 2DA. Big question. How do I get v all alone so that now I can solve my equation? And to do that, I just need to find the square root of v squared in both sides. When you square root v squared, you just have v, and now I'm left with the square root of 2dA. So once again, I rearranged the problem so that everything is equal to v. 18's up, I got smarter. I zoomed in so that I could write easier. I need v all alone. First thing I'm going to do is put things on top and bottom. I think it's easier to solve that way. Once I do that and I get v all alone, all I have to do is get rid of a by multiplying it to both sides. A cancels out. V is now all alone, just like I was at homecoming freshman year. And now it's v equals BA over C because you multiplied a to the other side. Problem solved. What do you think? Pretty okay? All right, this next one, we're kicking it old school a little bit for number 19. You got the length of a room is 16 meters, the width is 4.5 meters, and the height is 3.26 meters. What's the volume? You guys remember length times width times height is volume. So all we're going to do is 16.4 meters times 4.5 meters times 3.26 meters. Now, before we even get a number, ask yourself, what is going to be the units if I do meters times meters times meters? I hope you knew that was meters cubed, right? Then just throw the rest in the calculator, no big deal. You end up with about 240.59. But again, focus on that unit. That's meters cubed, okay? I like this one. Calculate how long you've existed on this earth since birth in seconds. Round off your age to the nearest year. Show all your work and indicate the cancellations of the units. So let's do some dimensional analysis, all right? Ooh, when I did my answer key, I was 38 for this problem, and now I'm actually 40. So I'm going to use 40 years old here. So I am 40 years old. Obviously, you are a different age. Now, I know that for every 1 year, there's 365 days, usually. I know, leap year. Let it go. Okay? I also know, because remember, I want to get how many seconds have I been alive, right? So I know that in one day, there are 24 hours. And then I know in 1 hour, because I want to get the seconds, I do happen to know there's 3,600 seconds. Now look at how beautiful this is. I didn't even have to think about what goes on top and bottom, what goes divide and multiply, because the units cancel out for me. That's a gorgeous thing. So I'm going to throw in the calculator, 40 times 365 times 24 times 3,600. You should do the same, but with your birthday. Let's figure out how old we are. In my calculator, I end up getting this, 1.26 E9. Do you know what that means? E9 means times 10 to the 9th power. So I've been alive for about 1.26 times 10 to the 9th power seconds. Technically, if we didn't round to the hundredths place and use scientific notation, I would be this number. I'd be alive that many seconds, which is, let's see, I'd be 1,261,440,000 seconds I would have been alive. Man, grateful to be alive, my friends. Every day is a gift. Every second is a gift, so enjoy it. Hey, I hope this helped you guys out in figuring a little bit more out about the math review, and come with specific questions. Remember, don't just come to class and say, hey, I don't get it. Be specific. Hey, number 15 is troubling me. I tried to do it, but I got stuck on this part. The more specific you can be about asking questions, the easier it is for people to help you. They know what you're struggling with, and then we can focus on the problem. All right, love you guys. Take care.